Hi, in this tutorial we will look at more questions on the existence of the limits of a function. Just a recall from tutorial 1. The limit only exists whenever the limit from the left hand side is equal to the limit from the right hand side of that number x equal to something. Let's look at example 1. Determine the value of k such that the limit of hx as x approaches to 4 exists. Remember, before we start to answer this question, there's a tip that I've showed you in tutorial 1, which is plot all of these functions on a number line. So we start at the value 4, and this means to the left of 4, so there's no equal sign there, that's why it's empty circle, and to the left of 4, write down the function and then do the same thing for x greater than 4. This is going to the right of 4, empty circle, and write down the function. Now, the question wants you to find the limit of hx as x approaches to 4. So remember, for a limit to exist, the limit from the left hand side must equal to the limit from the right hand side. So since at 4, as you can see from the left hand side, we have different function, which is this one. And then from the right hand side, we have a different function, which is this one. So that's why we have to check whether from the left and right side, they have the same limit value or not. But let's say if from the left and right side of 4 is just one function, then of course the limit exists and the value is just by substituting the x with that value. But in this case, there's two different functions from the left and right of 4, so that's why we have to do this step. So start with from the left side of 4, and remember, how do you know this is from the left side? Because there's a superscript of negative right on top of 4. Okay, so we have to change the function hx with the function which is from the left side of 4. So from the left side of 4, you can see from the number line that I've written. So approaching to 4, the nearest function approaching to 4 is the function 20x squared minus k. So just replace your hx with that function. So write 20x squared minus k here. After we have substitute hx with the function 20x squared minus k, what we have to do next is to substitute the value of x, which is 4, into the x. Notice that whenever we substitute the value x into the function, lim disappears. So there's no lim when we have substitute the value of x. But if there is still x, then there is still lim. Now, just simplify this. We want to determine the value of the k. To find k, we have to also find the limit value as x approaches to 4 from the right side of 4. So from the right side of 4, as you can see, the function is kx cubed minus 5. So replace hx with that function. And then after that, remember to substitute the value of x into this limit. The lim word will disappear. So 4 power 3 is 64 times k minus 5. So this is from the right side limit. So to determine the value of k, the question has given that the limits does exist. So remember, when the limit does exist, we can simply equate from the left hand side is equal to the right hand side limit. So just substitute your values that you have found from the left and also from the right. After you have substitute, and then just move everything of k term to the left side and numbers to the right side and then solve to find your k. The answer is k equal to 5. Now, let's look at example 2. The function fx is given, and then the question wants you to determine the limit if exists at x equal to 1. So this simply means we want to find what is the limit of fx as x approaches to 1. So remember, when we want to find limit, this means we want to find the limit as x approaches to 1, not exactly at 1. Okay? Even though it's x equal to 1 written here. Remember to start by writing down the functions on a number line. Look at the domain. The value is 1, so write 1 on our x-axis here. And this inequality stands for empty circle at 1, and then it moves to the left of 1. And then we have the modulus x. The next function is exactly at 1, so it's a dense circle. The function value there is 3. The last one is empty circle at 1, and then moves to the right of 1. The function is 2x minus 1. A common error that students always do in this type of question is they will simply substitute the function fx with the value at x equal to 1. So they will substitute it as 3, like this. And then they just equate it. Since there's no x there, so they just write 3. But this is wrong. Why is it wrong? It's because for limits, we have to look at the functions approaching from the left of 1 and also from the right of 1. As you can see, from the left of 1, the function is modulus x. And from the right of 1, the function is 2x minus 1. So it's not even the function 3 here. So if you write 3 and that's your final answer, then that's wrong. Remember, limit is whenever x is approaching to that value, not the value exactly at that x, okay? And since for this question we have two different functions from the left and also from the right of 1, that's why we have to write x approaching to 1 from the left, write a superscript negative on top of 1, and then we replace that fx with the modulus x. Then remember, whenever we have substitute the value of x into the x, which is 1 here, modulus 1, so we don't have to write the word lim anymore. So modulus 1 is equal to 1. Notice that in this example 2, I did not split modulus x to be two functions, positive and negative. Unlike in example 6 of tutorial 1, for this question, remember, where I split the modulus to be a piecewise function. Why did I do that for example 6 and I did not do that for example 2? Well, that's because for example 6, the question wants you to determine the limit as x approaches to 2. So if we did not split this into a piecewise function, then when you substitute x equal to 2 inside, above and below of this fraction, you will get 2 minus 2 over 2 minus 2, which is 0 over 0. You cannot solve that. So that's why you still have to change the modulus to a piecewise function. Okay, so just now we have found what is the value of the limit as x approaches to the left of 1. Now let's look at the value of the limit when x approaches to 1 from the right side. What is the function? The function is, when you look at the function from the right side of 1, the nearest function approaching to 1 is 2x minus 1. So replace fx with 2x minus 1. And then remember, when you replace x with the value which is given, then you don't have to write down your lim word. So 2 minus 1 is just 1. So does the limit exist? Remember, whenever the limit value from the left side is equal to the limit value from the right side, the limit exists and the value of the limit is equal to 1, since both of them is equal to 1. Let's take a look at example 3. We have a function f(x) and then we have 3 domains, which look a little bit more complicated than before. But don't worry, that's why I want you to draw the number line first before we start solving, because the number line helps us to determine which function to choose. Alright, so start with the domain. The first value, smallest one, is -1. And then we have value 2. And then we have 4. And 4 is the last number. Look at the inequality sign. So the first one is x greater than or equal to -1. So that means at -1 there's equal, so it's dense. But x is between -1 and 2. So at 2 here, there's no equal sign, so it's empty circle. So between means there's a line there. And the function x squared plus 2, write that right on top of this line, which refers to the function exists between -1 and 2. Next inequality sign. At 2, there's equal sign. So that means at 2 it's dense. And then at 4, there's no equal sign. So that's why it's empty. X is right in the middle, which means the line is right in the middle. And the function is 12 minus 3x. So write that right on top of this line. Imagine like you are sketching a graph right at this between these two value of x. But since for limit question, the question doesn't even want you to sketch the graph, so you don't have to waste your time sketching the graphs. We just want to make sure we determine the correct choice of function when you substitute in the values from the left and right of that x. The next inequality sign, there's an equal, so this means at 4 it's dense and it moves to the right of 4. The function written is square root of x. Next question, determine the limits if exists at x equal to 2. Remember, for limit, this is not exactly looking at x equal to 2. So if you do that, then it's wrong, because limit is actually looking at x approaching to 2 from the left and right side. You do not substitute in, let's say this is x equal to 2. You know that x equal to 2 is this function, 12 minus 3x. So you simply substitute in 2 into this function, then that is wrong. Okay? Because what you have to do is you have to look at the function from the left and also from the right of 2. Since we have two different functions from the left and right of 2, we have to look at it separately. So from the left of 2, the function is this one, x squared plus 2. Choose the nearest function from the left of 2. And the nearest one is x squared plus 2. Write that first, and then substitute your x with 2 into this function. Then write down your value. After that, find what is the value of the limit from the right side of 2. The nearest function from the right of 2 is 12 minus 3x. Then substitute your x with the value 2. Remember, when you substitute the value of x, which is equal to 2 for this question, the lim word goes. So the answer is also 6. Does the limit exist? Well, yes, the limit does exist, and write your conclusion. So that should be your conclusion, where from the left and right side is equal. So we can conclude that the limit as x approaches to 2 is equal to 6, because both of the limits value is just equal to 6. Same as in A, for B, when the question wants to determine the limit at x equal to 4, that means approaches to 4. So write x arrow 4. Okay, and then look at your function here. From the left of 4 and also from the right of 4, we have two different functions. So since we have two different functions here, we have to do it separately. Find what is the value of the limit from the left of 4 and then from the right of 4. The nearest function from the left of 4 is this function, the green colored function that I highlighted yellow. Why is it not this function, x squared plus 2? Well, that's because it's too far from 4. So just choose a function which is the nearest to 4 from the left side. And then just replace fx with that function. Next step is to substitute your value of x into that function. When you substitute value of x into that function, the word limit goes. The value of the limit that I found is just 0. Next, find what is the value of the limit from the right side of 4. The nearest to 4 from the right side is the function square root x. So replace your fx with square root x. And then just substitute your value of x into that square root. And the value of x is 4. So square root of 4 is equal to 2. Is 0 equal to 2? It's not equal. So since they are not equal, so does the limit exist? You should write your conclusion that the limit does not exist. Make sure to write that not equal sign. So the conclusion is the limit as x approaches to 4 does not exist. Now look at example C. The question wants you to find the limit as x approaches to 9. So x arrow 9, not x right at 9. But on our number line, there's no value 9. What we have on the number line is just negative 1, 2, and 4, but there's no 9. So we can just simply add the number 9 according to the order. So where is 9 supposed to be here? Negative 1, 2, 4. So 9 should be greater than 4. So it's somewhere there. Alright. So when we try to look at the functions from the left and also from the right of 9, do we have one same function or we have different functions? Well, from the left of 9, the function is square root of x. And then from the right of 9, the function is also square root of x. Since we have one same function from the left and also from the right of 9, for this question, I can straight away substitute the function fx with square root of x. And then I don't have to check from the left and right of my function. That's why I don't write the superscript negative or positive on top of 9. So since I know that from the left and right of 9, we have the same function, so it will definitely be equal. That's why I don't check. So square root of 9 is equal to 3. The value of the limit is 3. Do take note, when the questions want you to show that the limit exists, then you have to show the limit from the left of 9 and also from the right of 9. Okay, but since this question just wants you to determine the value of the limit, so I can straight away just substitute in square root of x because I know it's the same function from the left and right of 9. Thank you for watching.